Hey folks, welcome to Clear My Paper. Today we are going to talk about Cramer's Rule, one of the important topics in the syllabus and also in general matrices and determinants. And like I said before, the whole matrices and determinants for basic mathematics for the Maharashtra State Board first year diploma, I've divided into 9 types of problems, the overall syllabus, which includes both determinants and matrices. And Cramer's rule, if you see the one highlighted in yellow over here, it's a type 6 problem. It's one of the types. And in the previous videos, we have already covered the first few types, and then there are only few more types remaining. And we'll talk about Cramer's rule in this example in length. Typically, in the past examinations prior the MCQ pattern, for all the 4 papers from winter 2019 through winter 2017, each paper definitely had one problem related to Cramer's rule for 4 marks. So this is kind of important from that standpoint. Okay, so let's jump straight into that. So what I'm going to do is I'm going to take one of the problems. I'm going to take this problems over here, the one that is highlighted. Okay, this one. And the reason I'm taking this is I've already solved this problem in the previous sessions for different topics that I've explained. So that way all the topics kind of are related. When you explain something, there is a natural segue to the next concept of whether it's adjoint or determinants. So the same example can continue and I can reuse and explain you better so that you can go back and forth and refer to the problems in different contexts and understand the same thing across different dimensions. And that's the only reason. So I have solved one problem in detail in this video or in this session, and the remaining problems pretty much are straightforward. I'm going to copy and paste the solutions directly from one of the websites or the MSBTE website. They themselves offer solutions. I'm going to copy and paste for quick reference so that you don't have to go to different sources for answers. But in terms of explanation and solving, I'm just going to solve this one particular problem from summer 2019, question number 2A for 4 marks. So let's get started. Okay, so this is the question over here on my screen. If you see, we're talking about summer 2019 and it's asking to solve the equations by Cramer's rule. So whenever you get this kind of hint that it's Cramer's rule, so always remember we're trying to solve a set of linear equations. More than likely you will not get 2 by 2. You'll get 3 by 3 matrix where you have 3 equations and 3 unknowns, like over here whenever it's Cramer's rule. And whenever they're asking you to solve the equations, what basically their meaning is they're asking you to find the values of x, y, and z. So whenever they ask in different formats, solve the equations, find the solutions, okay, or find values of x, y, and z. Sometimes it could be called as inverse also, but in the context of syllabus, inverse is slightly used for finding inverse by matrix methodology. Then type number 9, which is the last thing that we'll discuss, type 8 and type 9, that's what they discuss, the inverse matrix. But pretty much inverse is also the same, where you are trying to find answers in form of other equation, where over here x plus y is equal to z is given in terms of constant. Then you're trying to inverse it kind of over here, inverse it, meaning that you're trying to find the constant, you're trying to express the constants in terms of x and y so that you can find the x and y and z value. So all are the same thing. So just kind of clearing your head on what it means. A quick word of caution. Problems like Cramer's rule, or generally in matrices and determinants, most of the problems, definitely Cramer's rule, they are time consuming. Okay, they are lengthy, they are time consuming. So when you try to attempt in the exam, although it will be easy, make sure that you are using your time judiciously in how you're going to solve this problem. And the good side is problems are pretty straightforward, easy. They are kind of mistake prone, so be careful while solving it, but the steps are very easy. And the great thing is the answers can be easily verified, right? So you don't have to really worry about that. You can put back the answers of x, y, and z back into one of these equations and verify whether the left hand side is matching the right hand side, which we will do in this video. So let's jump straight into the solution part of it. So whenever you get a problem for solving Cramer's equation or Cramer's rule or any general matrix equations in terms of 3 sets of linear equations or system of linear equations, the first and foremost thing that you should do is try to express the equations in a neat matrix format. So if you see here, these two things that I've put in here, I've nicely spread out the equations as equation 1, 2, 3 so that I can read it very easily without doing mistakes, because whenever you copy the numbers, you can always copy from the wrong set of equations. So spread it out, use the space nicely, write it down linearly like this, one below the other, stack it up, and then express in the matrix format, basically taking the coefficients and putting in the matrix without worrying about the remaining things, like how the matrix is done, because it's a condensed way of writing. It's more of an abbreviated way of writing a system of linear equations. So the first matrix is the coefficients for all the x, y, and z values over here. If you see here, just this part, I'm taking the coefficients of all this and nightly expressing it in 3 rows and 3 column format. The next matrix, which is called as the variable matrix, the first matrix is called as coefficient matrix. I've just labeled it as A. The next matrix is the unknown matrix or the variable matrix, which is what we are going to find. That is our goal over here. This is the unknown. And on the right hand side, we have the constant matrix, which is a list of constants. And you can always express this as in a super abbreviated form. AX is equal to B, all in caps. Whenever you write in capital letters, it means that you're talking about matrices. So we're talking about 3 matrices. And from a geometric standpoint, you can always imagine that this particular matrix is going to transform this matrix to give you this output kind of. So this is a transformation matrix. So if you're going back and forth in your mind from a geometric standpoint, the left hand side matrix is a matrix that is going to transform the matrix on the right hand side. Okay, so and a quick recap, because you will be using heavily determinants. And another important thing is Cramer's rule is nothing but finding the solution of the equations using a method of determinants or ratio of determinants. Always remember that whenever it's Cramer, that's another clue that it's nothing but finding determinants or ratios of determinants. That's the solution, right? You have to always find the solution by that. So in the exam, if you're blinking what is Cramer's rule, remember that, okay, it's nothing but taking the ratio of 2 determinants. And a quick recap, what is the determinant over here of a 3 by 3 matrix? You take any matrix, which is a 3 by 3, and you can choose, you have a choice. You feel free to choose any one row or any one column. That's your choice. The determinant does not change, okay? And the way you do is, in this case, if you're going to choose the first row, that is the whole of A, B, C, then the way you find determinants is you take a particular element in a row, and then what you do is you kind of take the submatrix of the remaining elements of a 2 by 2 matrix, which does not include the row and the column of the very element that you have chosen. For example, if you're choosing A, then this row and this column should be excluded, and whatever is remaining, which is highlighted in purple color, you should take the determinant of that. And I put a separate video on how to calculate this, but for ease of optics, I've just copied it here so that you don't forget it. So let's start finding our ratio of determinants. Okay, so what I'm going to do, I'm going to find the value of x, which is nothing but a ratio of dx by d. I'm going to find the value of y, which is dy by d, and I'm going to find the value of dz by d. Okay, and the important thing is the common denominator, which is d, which is nothing but the determinant of this coefficient matrix A, that cannot be 0. The denominator determinant cannot be 0 because we need the solution to exist. If it is 0, then the solution is not defined. That's the first check you need to do. So let's start finding the determinant of the coefficient matrix A. So for ease of purpose, I'm writing it down below here. Okay, and using this formula that I've explained, I'm finding the determinant. And if you see, I write it out kind of in a spaced manner, leaving enough space between this in algebraic signs and the numbers so that I don't mix and match. It's very easy to make mistakes, so don't do that. Use the space, write it in big font so you will not make the mistake. So like I'm taking here the first row. Throughout this problem, I'm going to take the first row for finding all the determinants, the elements on the first row. So if you see this and this are the first row, first column, I'm going to remove this, sorry. Okay. And if you see, I put it here. So first row, and then I'm going to compute this matrix over here, submatrix over here, and then here, and then here. And don't forget to alternate the signs, negative and plus. And then you'll get some value, which is in green here. So the determinant of the coefficient matrix A is equal to 6, which is not equal to 0. That's a good thing. That's a first checkpoint. Similarly, I'm going to find the remaining matrices. Let's start with determinant of the matrix, which is dx. And what is dx? Like we have seen from the previous matrices when we did the 2x2 video, whenever you want to find, when it says dx, it's talking about the column that represents the x variable. What is the first column? If you see here in the given problem, if you see here the first column, right, this whole part is representing x, and we are trying to find a determinant which is kind of dx. And what it means is I'm going to replace the whole column which represents the x variable, and I'm going to replace that particular column with the constant matrix which is on the right hand side, the 3 1 0. I'm going to replace it over here, and if you follow my orange color, you will see that this matrix over here has been formed with a replacement. So the x elements or the first column is gone, and I've got a new column 3 1 0, and that kind of gives me a new matrix. And I'm going to find the determinant of this newly formed matrix where there are no x variables, but the determinant will help me in finding the value of x, which we have seen in the previous videos, to give you an intuition. And I'm going to apply the same principles of finding the determinant of 3 by 3, where I'm going to take the first row. In this case, like I said, you can take any row, any column, doesn't matter. I'm going to take this row, and if you see in orange, I've solved the problem finding the determinant of dx, which is again is equal to 6. So I have the value of d, the determinant of the coefficient matrix. Now I have the value of x, dx, sorry. So hence I can find the value of x. Moving on, in the same fashion, I'm going to find the value of dy, where I'm taking the given matrix. I'm always rewriting it. It's a good practice for you to rewrite the given matrix before you kind of change it. And in the exam also, you can circle this and put it in a way. So the second column is the one that represents all of the y variables. So I'm going to knock off that and replace it with the constant output matrix on the right hand side, which is what I've done here. And in the old school fashion, I'm going to find the determinant of a 3 by 3 matrix, which is this new matrix, which is going to give me dy. And over here again, dy is equal to 6. So far all the values are 6. And moving on the same way, I'm going to apply the logic to find dz, where I'm going to take the third column, which is representing the z variables. I'm going to remove it, which is in orange, and I'm going to replace that with 3 1 0 over here. And then I'm going to use this newly formed matrix. This is a matrix, okay? And I'm going to find the determinant of this matrix in this fashion, again following the first row. And I'm going to get a value of dz, which is also 6. So all the values are 6. Now I have all the important elements that I need to find the value of x, y, and z. So if you see here, what I've done is I know that the values of x, y, and z by Cramer's rule are nothing but the ratio of two determinants, dx by d. So I'm going to apply all the values, and you will see that the values that I get for x, y, and z, since all the variables are same, is 1, 1, and 1. And that kind of concludes the solving the problem. But the quick thing is, how do I know that whatever values I've computed, I have not done any calculation mistake and the values are correct? And that's why you kind of put it back in the equation to do a quick checkpoint. So you can take all these values, you have all the values that you have, and what you can do is you can take any of the given equations. You have 3 equations. You can pick up any one equation. I picked up the first equation over here, which is x plus y plus z is equal to 3 from the given problem. Let me show it to you. Over here, I'm taking the first equation over here, this one. You can pick up any one. So I'm going to apply the values of x, y, and z, put it back here, and ensure that when I add it up, it matches on the right hand side. And since I know all the values are 1, 1, and 1, it will match. And that way I can doubly ensure my answers are correct. If you see here, I'm putting back the values 1, 1, 1, adding it up, and my left hand side does match my right hand side, and hence I know that my answer is correct and I secure my 4 marks in the exam. That's how you need to calculate the problem. So pretty much that's what it is. And always remember, Cramer's rule is not the best way to solve the problem, but since it was one of the earlier ways and it gives a lot of intuition on how determinant kind of plays, it's a part of the syllabus, and it's very important to know from the understanding the building blocks of matrices and determinants. And similarly, other problems, like I said, I'm not going to explain, but I've just copied and pasted it for ease of reference in one place, and you can apply the same logic in every problem, but always ensure in these solutions they will not put a step to put back the answers into the equation. So always put it back, these values that you get, the xyz values, or here sorry, the xyz values that you get, always put it back in one of these equations of your choice, and make sure that the left hand side does match the right hand side. That pretty much concludes Cramer's rule, guys. That's your 4 marks secured. Hope you enjoyed this video and it was easy to follow. Stay tuned for our next set of videos. I'll be there with some more interesting episodes on the next set of syllabus on matrices and determinants. Signing off on Clear on My Paper. I'll see you in the next video.